Hi, I'm Ben Guido, an environmental engineer and working as a global WASH coordinator for Israel. It is an Israeli-based international humanitarian organization. As part of my role in Israel, I encounter communities which are experiencing water stress and water shortage. I see the burden which is related to lack of water. As a student here in the Technion and as part of my research for my master's degrees, under Professor David Brodai and Professor Eran Friedler, we've developed a system which extracts water from the air. We believe that this technology is a game changer for remote communities and people which are experiencing water shortage and water stress. We've encountered this group of children coming to fetch water from the lake. The older girl around here, the one that's smiling, is the leader, and she's scooping water for all the smaller children, and when it's all full they go back to the village.
And the water is probably not safe.
They don't go to school, they don't have education, they don't have good health. Actually, they don't have a future.
According to the World Health Organization, in 2025, about 50% of the world population will live in areas with water scarcity.
Access to clean water in remote communities is actually a lifeline. It enhances gender equality, gives opportunities, and basically gives hope. This was the motivation that drove us to develop these atmospheric moisture harvesting systems that can be deployed in any remote community.
My research assignment was to build a model which will simulate the performance of the system in various climates and environments, such as the Sahara Desert or any other arid region.
Current available technologies cool the whole bulk of the air mass and condense the water out of it. Since there is limited amount of water in the air, they require a lot of energy to produce fresh water. Our system first separates the moisture from the air and secondly cools only the water vapor. Therefore, it requires less energy to produce the same amount of water.
Water vapor consists at the maximum only 3% of the air mass. Thus, when we separate the water vapor from the bulk of the air before cooling it, it saves us basically the majority of the energy needed. Not only that, but we can deploy the system in off-grid places where there is no electricity.
We are here in the pilot plant of moisture harvesting technology. The blower feeding the system with the ambient air. The air is flowing into the tower. The brine that collected the moisture from the air is going from the tower to the generator. The vapor is flowing up to the condenser, where the water vapor is condensed to a liquid form and flowing out of the system so we can harvest the water.
In the current technologies, the whole air body is cooled, and that's why air pollutants might be absorbed on the system and find their way into the produced water. In our system, if there is any bacteria, it will be killed by the very saline solution, which is about 10 times more saline than seawater.
מים האלה יותר נקיים ממי גשם. This technology can function in any climate, in particular in desert areas. It can supply fresh water to communities that live in remote areas.
דודי, בוא תסתכל איזה מים.
מים מהטבע. לחיים.